So what have we done last week? Right? I'm going to summarize. I'm going to put that in summary. I'm put that in summary, right? We had done the 8 functions, right? We've done all these exponential functions. Right? We did all of these, right? Domain and range. Do you guys have any questions? Okay, I'm going to bring the 8 functions with us. We've done that, a nice summary, didn't we? Could you guys bring me questions? The 8 functions. Okay, so I'm going to do this. Okay, so I'm going to do it in one stroke. Do you guys have any questions? So far, we have done all of these, right? The first 8 functions and then the exponential functions, right? And these functions are being covered from beginning from pre-algebra to all the way to well, what else? College algebra. All right. So this is across multiple textbooks. And today we're gonna study. Remember the one-to-one function we talked about?
Yeah.
Do you still remember the definition? Remember, I'm teaching this class. I also have in mind, I want to train you to think when you take calculus class, how to apply definition. Okay, so that's what I try to get you to do. Okay, do you still remember the definition of a one-to-one function? Can you get that flashcard in front of you? Whenever, yeah, x sub 1, whenever the input are different, their output are different also. And built on top of it is a function. Okay, function is a rule that assign each input exactly one output, f of x. One-to-one function, right? So when you look at these 8 functions plus the following function we studied last week, can we go over them once again? You're going to tell me which one of these are one-to-one functions, and we're going to do something about them. Okay, we're going to do something about them. Now, is this constant function one-to-one?
I want to say no.
No, yeah. How about this one? Apply the definition. This is recap. We've done it before. Right? In calculus class, you just applying those definition over and over and over and over again. This way and that. That's what you do, really. Is this one-to-one? Is this one-to-one? Is this one-to-one? Yeah? Is this one-to-one? Is this one-to-one? Is this one-to-one? Is this one-to-one? I'm gonna give you 5 minutes. 5 minutes. Okay. And I'm gonna step out just for a few minutes. And Farouz, you're gonna take
Yes.
over. Okay.
Okay.
And tell them, go over the definition and just briefly go over this 1, 2, 3, 4, 8 functions. We're reviewing this, right? We learned this by repeating, and all of these functions, whether they're one-to-one, increasing, decreasing, do work on that. Okay, everybody has a notebook in front of you. Okay, we're recapping what we have learned last week and after that, we're going to move forward. And we'll continue to do that next tomorrow. Okay, I'll be right back. Okay.
Okay. Thank you, Professor.
There's 5 minutes. Okay, thank you.
Hello, everybody. Good morning. You can bring your question to my attention. Let's see if I can help you maybe simplify a little bit or build up some confidence. Okay, I have my board ready. If anybody has question, bring it up. For example, what we see on the screen, these are in the same family of what type of functions? Any volunteer to answer?
I don't know about anyone else, but I don't really have any questions on this part of the
Okay. So yes, usually when professor asks, waits or pause for receiving answer from class, those are the times you can respond, and so she knows how much to spend time or not. When no response, she might think the student don't remember or forgot all those things. So thank you for responding, Nicholas. I saw Jacob and Nicholas mainly responding once in a while in the chat, a couple of more students. So we are about 20 students. Me and professor together, shows 22 people. So yeah, if you have any question, bring it to our attention now or in the Math Study Center. Responding to professor's request, what we see in the screen right now, they're all from what type of function? When you see they're going up, right? From left to right, looking at the graph, they are the same family of what? Exponential? Yes. Yes. Thank you, Wilbur. Good job. Exponential functions. So within all those exponential functions, f of x equals 2 to the power of x, e to the power of x, and so on and so forth. You want to choose one of them, maybe e to the power of x, and then look at the graph, look at the equation, the function, and try to start from there and, expand that property to everybody else, all those exponential functions. Same domain range, intercept, so on and so forth. Okay, Professor.
Thank you so
Yes.
much. I really
Okay.
appreciate it. Okay, so
Yes.
now that you see, we have, you guys have, you know, for a quick decision whether it's a horizontal or whether it's a one-to-one function, you just have to do the horizontal line test, right? You already have the graph, right? We already have the graph. We have talked about those in last week's lectures. So if you have a picture of the function, it's very easy to decide whether it's horizontal or it's a one-to-one, is not a one-to-one. Among these four functions, and we know that this is only one-to-one, right?
Professor, there is only one output for any one input except 0 on that graph. Is that
Right,
one-to-one? Is that still considered one-to-one?
right. Exactly.
For X is input 0, what is the answer?
Undefined.
Undefined is the answer. Very well. Very
Yeah.
well. Thank
Undefined,
you.
right?
Yes.
0 cannot be in the domain. You can see on the picture, you're not going to see it. You see this function, as simple as it is, you're going to use it a lot in calculus class, because its variations are going to show up here and there. There'll be many variations of these, and I'm going to, you know, throughout the semester, you're going to see these basic functions will blossom into more complicated situation, okay? So now we're still talking about the basic. You must make sure you understand the basic, everybody. Okay, if you don't understand the basic, it's very hard to understand the complicated. All right, so among these four, this is a one-to-one, okay? The next question is, what are we gonna do with it? Today, we're gonna talk about if a function is one-to-one, then it has inverse. If it has inverse, we're gonna find that inverse. And what does inverse mean? Okay, this topic is across the multiple courses, as I mentioned before. It's probably permeated throughout, like, you know, college, intermediate algebra, college algebra, and then trigonometry. So this concept is going to permeate throughout these courses. So they're not alone. So we're going to start from simple. So today we don't have a whole lot of time left. So I'm going to work on this function. I'm going to show you what to do. Okay. I'm going to put it here. I'm going to use this one as an example. Okay, first, okay, write this down. If a function is one-to-one, it has an inverse. What is more, it has exactly one inverse. Okay. There will be confusions, okay? I know there will be. So let me explain what is inverse. So suppose a function is one-to-one. So if you look at the function situation, right? From input, it produces output. What does the inverse do? Okay, so suppose we have a function we called f. Suppose we have a function called f. And since it is one-to-one, therefore it has inverse. That inverse I'm going to call f. This is the notation, okay? You're going to see this notation. This notation is a little too, let me make it larger fonts. Can you see the negative sign, -1 on the shoulder?
Yeah.
Okay, so this function is 1-to-1. So it is, since we already know it's a given. It is 1-to-1. Therefore, it has exactly one inverse. What does it mean exactly one? One and only, right? Exactly one. Unique. Unique. So what does the inverse do? Okay. So now, if we know that for the function, there's a domain. There's a domain. So the input is taken from the domain. Okay. Where's my other symbol here? So this x is from the domain of this function, and f of x will belong to the range, right, of the same function. The inverse function is also a rule. The inverse function is also a rule because it's a common function, right? The inverse function will take input and output as well. Do you guys follow me? But what is the input? The input of for the inverse function, suppose we can call them anything, right? Let's call them x again. Typically, they're going to be called x again. But these x's are going to be from the range. It's going to be from this range. This range will be called a domain. Okay, so this range goes here. I'm going to put an arrow there. Okay, so this is a domain. This is a range. So you're going to have an output. This output is just write it down for now. I'm going to draw some. So this is the range. In this relationship, okay, this domain for the function and the range for the inverse function, these two are the same. Okay, and the range for the function and the domain for its inverse, these two are the same. Do you follow me?
Together, they can make a loop.
Yeah, we're going to see that loop. Absolutely. Do you follow me? This is the mechanism. This is the mechanism in general, consistently. Mathematics is anything that has to be consistent. Okay, math has to be consistent. Anything you expect from math, number one thing you expect is going to be consistency. Okay, so I'm going to show you. So number one is how do I find that inverse? Wait, oh, wait. Okay. Do you guys understand that relationship? The inverse relationship. Oh, sorry, I don't mean to have that arrow. If a function is 1-to-1, it has exactly one inverse, and there's a domain and range. And the next question is, how do we find it? How do we find it? Let's find a inverse. Let's find an inverse. You guys might have seen this before, but you might not have seen this before, but it's okay. Okay, so I'm going to remove those arrows, expecting you guys have written them down. So let's find the inverse just for this particular function. Okay, now, because we know this function is such, right? To find inverse, the general steps are the same. So we have f of x here. The first step, step one, is swap. Swap, in the past, you might have learned, we swap x, y. Where's my arrow? We swap x, y. What does it mean swapping x, y? This guy, okay? The place of x and y switch places. This is swap, okay? Represent the swap of domain and range. The swap of domain and range, domain and range are also swapped. You follow me? Yeah?
Yeah.
Step 2. Solve for y. Solve for y. How do we solve for y on this case? All of these operations we work with is in the what? It's in the proper domain. So when we work with this function, we implied we're working in the domain of the function. So you don't have to question. So when we swap the domain and range and everything works perfectly, you can assume that domain range. But when we swap it, the domain and range is swapped at the same time. But in this case, domain and range are the same. Do you guys see that? The domain and range are the same. You follow me?
Mm-hmm.
But there's still a swap taking place because in some cases, they're not the same. Okay, so today we won't get to those examples, but tomorrow we will. So today we just talk about the method. So what do we get when we solve for y? We can just treat it like this, right? We can just treat it like this. Oh, hold on. We can just treat it like this. X is what? It's x over 1, right? And we flip it upside down. So y equals what? 1 over x. As a result, the inverse function is going to be 1 over x. The inverse function is going to be 1 over x. This is the only function. The function and its inverse are exactly the same. This is the only function that the function and its inverse are exactly the same. So that means they have domain and range. They have the same domain and range, everything the same, right? So that's why sometimes it's not being mentioned and a lot of details is overlooked. Okay, but because this function is so important, you're going to use this function over and over and over again in calculus classes. Okay, I'm addressing these issues. So domain is swapped. Now, let's look at the other mechanism I think Farouz was trying to talk about, right? The domain swapped. So suppose we have a function. So the next thing we're going to talk about is that suppose we have an input. This input is given to f. Okay, it produces an output. It produces an output. And this output, okay, this output is going to be in the range of f. If it's in the range of f, it's in the domain of its inverse, isn't it? Because these two are the same, right? You follow me?
Mm-hmm.
And then I can take this guy as the input for the inverse. And then what happens? It will inverse. Okay, hold on. Let me complete that inverse notation. And it produces an output, and that output is like this. And the input is f of x. What should this be equal to? This is going to equals to x. Okay, you look at this machine, right? Now we have two machines. These two machines are inverse to each other. Inverse to each other. Okay. The input given to f produces f of x. F of x is given to f of inverse. So this guy is the input now because that the range and domain is the same, right? So this guy is given to inverse for input and producing an output. That output is going to be exactly the same as the input we started with. Now, another scenario. I take an input from the inverse. Okay, so I give to F inverse. F inverse. F inverse. And this is going to produce me F inverse of X, F inverse of X. Okay. Why these symbols, why X is being used, even though this X is from the domain of F and this X is from the domain of F inverse. Okay, so F inverse of X, that's the output after the rule of F inverse is applied to it. And then we're gonna, and this, so this guy is in the range of, hold on, let me grab this over here. Okay, I'm gonna grab this over here. So you can see that this guy that taken from the domain of the inverse produce F of inverse of X is in the range of F inverse, and that's the range, but this range and that domain are the same. Therefore, this can be used to apply this rule, can be applied the function rule. As a result, we're going to produce, okay, F of the input is this, and it's going to be exactly the same as the input. I know you might feel dizzy a little bit. Is that right? But no fear.
Bad.
Okay? No fear. I'm going to give you an example. I'm going to give you an example to conclude today's class. Okay? And we'll continue this tomorrow. Okay? But this is going to be the theme for some time. So we're going to repeat this over and over for different rules and their inverse. Okay? So don't worry. Just hang in there. Hang in there. Because this is a, I promise you, I will hold your hand to get you there. Okay? For example, I'm given the 2, number 2 to F. Okay, so now we have a F. This function is equals to 1 over X. And its inverse, the same, right? We just did it. The inverse is also the same, 1 over X. Okay, these are the F and its inverse the same, and this is the only one, okay? This is the only one in the whole wide world. This is the only function that the function as inverse are the same, okay? So now, and the domain and range are the same, so this is, there are a lot of sameness, so, right? So this is the perfect simple examples to demonstrate. And there will be other cases we're gonna see coming along our way. So now, 2, first, I'm going to give it to F. F. What is F of 2? This is F of X, right? So what is F of 2? If the input is 2, the output is half, right?
Yeah.
Right? Now I'm going to take this half and give it to F inverse. This rule. So it's going to come out. What does it come out with? F inverse of what? Of half, right? What is F inverse of half? F of x, F inverse of x is 1 over x. Now, what is this? So this input is going to go here, right? Complex fraction, right? So 1 divided by half. 1 divided by half equals what? How many half in 1?
2.
2. Aren't they the same?
Mm-hmm.
Okay. One more. Suppose I give an input 3 to the inverse. Inverse.
Professor,
Okay.
is that a typo on line 2? Is it?
I'm sorry?
On line 2, is there a typo? I guess you meant arrow, but it shows a negative sign after the box. F
Oh,
in-
yeah. I'm sorry. It's arrow. Thank you.
You're welcome.
Thank you,
Thanks.
Farouz.
Thanks.
Thank you. So F inverse of 3, F inverse of 3, what would that be? This is F inverse, right? So when the input is 3, the answer is what? Is 1/3, right? Yes,
Yeah.
right? You just plug in, right? Just plug in the numbers, plug in 3 and plug in 3. Anybody has any questions here, please? Okay, so I'm now 1/3 is the output. Now I'm 1/3 is in the domain of F, right? Therefore, I'm going to apply F. F is applied to F of 1/3. What is F of 1/3? And that's going to be 1 over a third, right? What is 1 over a third? That's a 3. Output exactly the same as input. And this is true forever for this pair of function. Okay, last but not least is that suppose I give any input from the domain of F. So I'm applying the F, and it's going to come out as F of x. Sorry, F of x, which is going to be 1 over x. Right, apply the function, and then I'm going to apply the inverse. Oops, F inverse is going to come out as F inverse. This time my input is 1 over x. Do you guys see that? F inverse is 1 over x. Therefore, plugging in 1 over x is going to be 1 over x. And that's equals to x. Okay. I expect you guys to ask questions, guys. Okay. So this is the last line I'm going to cover today. So this input x is going to be from the domain of F inverse. It's going to come out F inverse of x. And then I'm going to, and this of course is my output. My output is 1 over x. And then I'm going to take this output and serve it as the input for F and it produces f of 1 over x. And once again, it's the same drill. So to summarize this property, is here. This one, that one, these two properties. Now, the question you say, oh, you see this x and this x, they're all we use the same symbol. How do I know which one is from where? Okay, here's the clue. If you give x as input to f, this x is going to be from the domain of f. If you give the x to f inverse, and this x is supposed to be from the domain of f inverse, and these two functions may not have the same domain, okay? This time we just happen they have the same. Sometimes they don't have the same domain, and that will also be true. So when you judge the input is entirely decided by the function. All right, I'm gonna leave you guys at this, and this has been, so we count this as introduction to inverse function. Okay, we have a bigger picture ahead of us. The bigger picture is that we're gonna handle the exponential function and its inverse. And then we're gonna cover the trigonometry functions. And these are like 2-3 courses, you guys. You can't afford not to pay attention and not to ask questions. This is 2-3 courses. Do you agree with me, Farouz? You don't have to.
Absolutely, no, absolutely.
Absolutely. Okay, so please do pay attention, get to every details, but I promise you're gonna repeat over and over and over again. All right, in different mode, different examples. Okay, so that's all for today, and our quizzes are going to be closely related to my lecture. All the answers you need for your quizzes, they are all in the lecture. If they're not, you should let me know. Okay. I'll see you guys tomorrow. Good job.
Thank you, Professor.
Bring your questions, please. Okay. Let me know more about you.
All right, thank you. Have a good day.
Thank you.
Thank you.
Have a great day. Keep up with your good work.